You don't like that?
No.
Yeah.
I feel like I don't get credit for the test.
Oh, yeah. Maybe we'll put a quiz or something on there and see how it goes. All right, let's try this right here. Let's kind of do it quick here. And we'll put the y-axis about right there. All right, what's the only thing going on here? What's the only thing changing to your original parent function, your original sine theta graph? What's changing? Yeah, you're moving it to the right. How many places? Or not, I shouldn't say places. How many degrees? 90 degrees. Okay, so let's put some points in for the normal one. We don't even have to graph the thing, and then we'll just put our new points in there, and we'll graph it from there. All right, so the period's still 360, right? So if we break it down like this, we should know our numbers. What would the first one? Well, it's 360, so that would be 360 right here. This is 0, and then halfway is 180. That would be 90. And this would be 270. Again, if it was radians, what would this be? Quickly. 90. It'd be pi over 2, then pi, then 3 pi over 2, then 2 pi. Okay? That's really the only difference with radians. It's really not that much more difficult. All right, our amplitude is what on this? It's 1. All right, so pretty good. Now, what would it look like? The sine. Do you know what the sine looks like? Do you know where it goes through now? It goes through where? The 0, doesn't it? But this time, let's change colors. It's not going to hit right here. Where's it going to hit? It's going to push over to here, isn't it? All right. And instead of 180, let's see. I'll tell you what. Should I graph the thing or not? Or should I just push everything over? So it was here, right? At 90, the regular sign was up here. So where does that go? That goes up here. So where do you think it is at 0 now? Because at negative 90, where was it at negative 90? It was at negative 1, wasn't it? But if I move it to the right, it's going to be right here, isn't it? So really, once I do a couple points, the rest is pretty easy to see. You kind of know what this graph's going to look like. So it's going to start here, go up like this, and what it's going to do here. Because it was at 180, it was at 0, wasn't it? We just pushed it over, and what do you think here? See, once you just get it started, you don't even have to think about that stuff shifting over. You know, once you get a couple of those, you're like, oh yeah, okay. If it starts here, then it's going to go through here, it's going to top off, it's going to go like that. And you kind of get that whole idea of what it looks like. So this is what it would look like. Oops. Just hit it. Come on, pen, help me out. There we go. Like that. Like that. Oopsie daisy. There we go. My graphs aren't so bad. Like I said, I've been looking at other people's, videos, and my little graphs sometimes are better than other people's, but some people do better than I do. Yes.
Why does that start at 0?
Because the regular sign starts at 0. We shifted it to the right. That's what this thing did right here. Okay, it shifted it to the right 90 degrees. All right, the regular sign would be here, but this is theta minus 90. So we took this and we moved everything. It was here, right? The regular sign, but what did we do? We moved it to the right. At 90, where was it? It was at 1, but what did we do? We moved it to the right 90 degrees and so forth. Okay, that's why we pushed everything over. So really, in a sense, what did we do? We just picked this regular sign up. We just picked it up and then shoved it to the right 90 degrees. Make sense? All right, let's do another one. Well, I was going to write this down while it was paused, but that's okay. So it's y equals, here we go. This is example 3 if you want to follow along. Now we're still doing the sign. And look at this. It's 2/3, and then it's theta minus. They put pi, but is that okay? What's pi? Oops. It's pi. It's 180, right? Plus 4. Now again, I probably should get you guys used to pi, but maybe in the next chapter we'll do a lot more with pi, okay? I'm just trying to, again, ease you into it. So what in the world's going on here? What does that tell you? That's the amplitude. So it's just going to go up to 3. So instead of going up to 1, it just goes up to 3. So it stretches out a little taller, doesn't it? This talks about now it's not the period, but it changes the period. So the period is 360 divided by 2/3. Now, if we did this in radians, it would be, instead of 360, what would it be? It'd be 2 pi divided by 2/3. You follow me on that? So it's really not that big of a deal. So really, what is it? It's 360 times, or over 1, sorry, times, dividing by 2/3 is the same as multiplying by 3/2. So that goes, what, 180? And what's 180 times 3? It's 540. Okay. To tell you the truth, in radians, that might even be a little easier to figure out what that is in terms of pi. But anyway, it's 540. That's the period. All right, and what does this do? This picks it up and moves it up 4 places. Now, we didn't do an example like this, but we do have to talk about something here. So let's see if we can do this quickly. I don't know if we'll be able to finish it up. But it's in the book, okay? Maybe in the next class, because I took some time getting stuff copied at the beginning. Maybe in the next class I'll have time to finish this up. So if you really want to go and look at it, at a little bit longer explanation, you may want to go to the Part B class, and we may have it done there. All right, so now let's go to blue. All right, so the amplitude, let's do that first. So how high is it going to go? It's going to go to 3. That's the amplitude right there. And then that's going to go down to -3. Well, we got to think about this a second. We're going to change something, because really what we're going to do, we might need to put some more stuff on here. And I think I'm going to run out of time, but because this does take a little bit of explanation. I'm going to make this go up. Come on, pen. Where are you? There you are. Okay, like that. And let's just put some in there. That's 1, 2. -1, 2, 3. You follow me so far? The period is 540, so we're going to come out here to what? I'm going to go about right there. Okay, so 540. Let's fill some in. What's half of 540? 270. Okay. And then half of that? 135. And then what's in between 270 and that? 405? Okay, good. All right, you with me so far? All right, it's sine, so the normal sine would start here and it would go up. It'd top off right here, wouldn't it? Let's say we're talking about not even having the 4 there for right now. Okay, let's everything else. Let's say, and we're talking about not having the phase shift right now. So we're going to take this, we're going to pop it up here like this. It's going to come down. It's going to go like that. I tell you what, let's do that in red. Now this is not the actual graph. This is what it would be without the what? Without the phase shift and without the vertical shift, correct? So this is what it would be without both shifts. And like I said, sometimes it's good to draw this just so you can have a comparison. Sometimes it's easy to do that, all right? So let's go back to blue. We'll keep the real one in blue. We have to shift this which direction? To the right, 180 degrees. So it was here. Now this is a little bit tough. Where's 180 degrees? It's how far from here? 45 from here. Is it 1/3 of the way? Okay, it's about 1/3 of the way. So really, 180 degrees is right there. And it does. It moves from here to here, doesn't it? So, and what is it from here to here? That's 45, isn't it? From 135 to 180, that's 45 that way. So basically, at every one of these points, well, nah, let's not say that. Yeah, we could just rewrite the degrees and put it in here, but I just want to keep everything with that. So we shifted it over 180, so where's our point going to be? Well, it would be here, but we also got to talk about the vertical translation. But let's just talk about the shift right now. Is that all right? So we're going to, it's going to be a little bit messy, but hopefully we'll figure it out. I'm sorry, you're absolutely right. So we took this point right here and we shifted it, so it's going to be right here. Now watch this. Let's take this at 135. Basically, you just add 180 to it. What's 135 and 180? 315. So that would be 45 from here, wouldn't it? Okay, do you see that? So there's your 315. And so we take this and we move it up here like that. So you see what's going on? So really it's starting here and it's going like that. And we move this 180 degrees. What's 180 and 270? That would be, let's do that real quick for me. 450. Okay, and so that would be right here. Do you see that? All right, so I'm taking this point, I'm going here, so it's going to come through like that. And you can kind of see what's going to go on. You're going to push this. Now what are you going to do? You're going to take this. It's not going to go through this x-axis. What do we do to this x-axis? We actually have to take this x-axis, right? And, oh, come on. Right, and we got to take this and move it up. How many places? 3, 4 places. So what's our point going to be here? It's going to be 4 at our center line. We call this our center line or midline, and it goes up 3. So really it's going to go up to what? 7, and it's going to go down to 1. Not -1, just down 3. 3, 2, 1, right there. So it's going to be this little blue line all picked up, and it's going to come way up here like this. All right? Well, you don't actually move it. I just did it to kind of show you. Hopefully I'll have this finished. If I don't have it finished, then I'll do it at home nice and clean, okay, and I'll show you exactly what it's supposed to look like, okay?